Now we're going to explore the OR operation. So in the OR operation, the output X is high when A is high, or when B is high, or when both A and B are high. So in the OR operation, the output is only low, it's only 0, if all inputs are 0. So it works kind of opposite to an AND gate. So let's go through and look at what the logic gate looks like when we draw it, make the truth table and the Boolean expression. So the logic gate is the OR logic gate. And we're going to make the OR truth table. And we're going to make the OR Boolean expression. The OR logic gate looks a little bit different than the AND gate. The OR logic gate is curved at the inputs and pointy at the outputs. This is OR. It does matter what shape you make your logic gates because that's how we communicate what they are in drawings. A, B are the inputs, output is X. And the Boolean expression, output X, is equal to A or B. This is not addition. So this symbol does not mean addition. This means A or B. So we have to, in this course, stop saying A plus B, and we need to say A or B whenever we see an addition sign. So output X here, sorry, I'm fumbling with my technology. Output X is equal to A or B. And so armed with this information that the output is only 0 when all the inputs are 0, we can make a truth table. So let's just put a summary here. Output X is only 0 when all inputs are 0 or low. Now our truth table, here we just have a 2-input logic gate, so A and B. So we know there's only going to be 4 lines on our truth table. So they're going to be 0, 0, 1, 1, 0, 1, 0, 1. Those are all the possible combinations. And output is only going to be 0 when all inputs are 0. So in this row, I see that all inputs are 0, so the output must be 0. The rest of them, this logic circuit is going to be output high. If A is high, so here. If B is high, so here. And also if A and B are high, then the output is high. So this is the truth table for an OR gate. So please memorize this OR gate truth table. You don't really have to memorize the whole table, but you have to memorize the fact that all inputs have to be 0 for there to be a 0. The rest of the outputs are all going to be a 1.